So we have the bushing and we have the cap to go on the end here. Next up, I was going to take this guy and make it to design it around holding the CO2 cartridge. But the more I think about it, this thing's so heavy. I mean, my design even was based on the shape of this piece of scrap, but this thing weighs so much, and a lot of times people like to leave this piece on after they put the CO2 in just for a while. I mean, that's how they store it quite often. So I think I'm going to try and make this out of aluminum instead of brass. It won't be as nice looking, but it'll be a lot lighter. This thing's quite a few pounds. Even after I hollow it out more, it's going to be quite heavy. So I think we're going to proceed next with that. Need to reduce the outside diameter of this part by about 50 thousandths. So we're going to turn it between centers. We're going to do a 25 thousandths pass just with a fairly high feed rate, 9 thousandths a revolution. Still can't break a chip though. My brother-in-law has a thing for knurling, so we're going to put a bit on the back section of this. That should make him very pleased. He really likes it for some reason. For decorative purposes only, I'm going to cut some little indentations on this. Okay, I think that's pretty. When I let the knurling wheel stop, I was getting only one wheel. Looks like more or less cutting most of the way, and then at the very end I got the cross pattern. That's kind of interesting. Not quite sure why that ended up like that, but we'll go with it. I think we're going to start with the through hole here. And this one's approximately a quarter. The actual size doesn't really matter. This is a drill bit with a heavy spiral, so it's really good at ejecting chips. But that does make the web in the middle smaller, so it is more prone to deflection. Next up, we're going to go in about 2.6 and we'll bore the final depth. Huge amount of stick out here, and we're going in quite a ways. Oh, we're doing depth on that one. Okay. All right, well, let's see where we are diametrically. I know I left a little material there. .715. So we need another 15 thousandths off this. We're gonna fill this guy with some lube. We're gonna do it again. May have to slow the RPMs down a little bit, I don't know. Just getting a little bit of chatter out here. I can dampen with my finger a little bit. Okay, let's pull the packed chips out. And let's go to our final depth. A lot of chips in there. I'll bring you back. Okie doke, so we got the whole board out with just a little bit of slop. I left about 10 thousandths oversized because I'm not sure how accurate these are sized, so I didn't want some of them to get snug and stuck. So I think that'll be pretty good. So we got it to depth. Now we're going to bore out for the threads, and we're shooting for 0.886 to a depth of 0.675. It's the 50 thousandths. Next, we're going to bore the back relief behind the threads here, and we're going to go into a depth that I've preset at 0 here, which is the 0.675, and we need a total depth this way of the thread thickness plus a little more just for coverage, so we're going to go in 60 thousandths. You're not going to be able to see much of this, so I might as well just bring you back. I'll start it here. I'm not sure you can catch this. I'm trying to show you the back relief in here for the threads. So next up, we're going to thread this guy, and hopefully we'll get the threads all the way back. I think I left enough for leaf space there. So I'm going to remount this, and we're going to tap this. As has been common throughout this project, I have to use a crescent wrench because taps this size, the tap handle will not fit between the center of the spindle and the ways. So this will be a bit of a lengthy process, so I will bring you back. Last step, we're just going to part this guy off. Last step, we're just going to clean up the face off this guy. Okay. So the hole on the end is purely to let air out when you're sticking the cartridge in and out, because you don't want it to get a vacuum behind it. Now for the assembly, so we take the old cap off, that'll probably never go back on. Put the new threaded brass portion on, and we're going to want this to live there. So towards the end, we'll give it a snug here. So here's the protective cap that can live on it, with my emblem in the beginning, in the middle, even though it's upside down. There you go. I don't know if that even shows. That was a little touch my wife suggested. I keep forgetting to do it. And then this guy will thread on with a cartridge. Alrighty, so I don't know if you can see this. There's water in there up to the fill line. Incredibly thick bottle. Rubber seal. screw on the top. Now, before I even do this, I'm going to tell you I've never used one of these before. Well, I have used the whipped cream style, but I'm guessing they're very similar. Take a brand new cartridge, you can see there, undone. Pop it in. And it ejected very nicely. I don't know if you can see this, but there's mist inside where the pressure increased rapidly. So now there's a vapor cloud in there. Should be able to pop this guy off. Eject the old cartridge. Put the cap on for protection. Good to go. Now we'll see, I guess, if nitrous works. Doesn't look like it carbonates very well, but it does work as a propellant. There's little bubbles you can see. It doesn't carbonate like carbon dioxide, so I guess the solubility is not as good. But it looks like it works pretty well. Well, thanks for watching. Hope you find it useful. Hope to see you next time.